Okay, in this video, we're going to do pages 69 and 70, which are tangent lines. So in the previous lesson, I didn't make a video because it was all just vocab. And so this is now looking at specifically tangents. So in the last 2 pages of notes, we saw that tangents are lines that intersect a circle once on the circle. And so a tangent line here would be line L. So line L is the tangent. And then remember, we talked about also the point of tangency. So looking at this diagram, that would be point A, where the radius is AB. And so if a line is tangent to the circle, then it is perpendicular to the radius drawn to the point of tangency. And so looking at this diagram, what this means is that line L is perpendicular to the radius AB. And so that's true for any tangent line. The converse, remember converse just means to switch the theorem's order, is that if a line is perpendicular to radius of a circle, then the line is tangent to the circle. So if I know that AB is perpendicular to L, then that means L is a tangent line. Another situation that we're going to see is when we have 2 tangent segments. And so if those 2 segments are tangent to a circle from the same external point, so these are both coming from point C, then those 2 segments are congruent. And so what that means is that in this diagram, CB is congruent to CD. And so what we're looking at here is that our points of tangency occur at B, and so we know that again because it's perpendicular. So if I have that diagram, that means that those 2 segments are equal. I like to think about this as an ice cream cone. So notice that we have the circle and then kind of this triangle that's coming out on the side of the circle. Your ice cream cone needs to be perfectly equal on both sides, or else, because if it was one was a little bit shorter, right, the ice cream would fall out of the cone. So that's a good way to think about how this picture looks and what that means for congruencies. So we're going to start with the first theorem, where we're given some tangent lines and we're asked to find missing pieces. And so for problems like this, we're actually going to be using more of the Pythagorean theorem because we have these tangents. And so what we know is that we're going to have these right angles where the radius meets the tangent line. Okay, so that's how we will solve these problems, is by thinking about it as a right triangle. So in this first diagram, we have this side as our hypotenuse. So they're giving us that the whole length across from the right angle is 9 units. And then they're giving us that the diameter, and so I'm just going to call that A, is 7.2 units. And then what we're looking for is, I'm just going to call that B. Since they're using a question mark, we can call it X, just so that we can have variables within our problems. And so for all of these problems, what we're going to use is the Pythagorean theorem. We're going to plug into A squared plus B squared equals C squared, because we know that these are creating right triangles. So for each of these problems, we're going to plug in using that idea. So if A is 7.2, we're going to do 7.2 squared plus our B we're calling X squared equals our C is 9 squared. So if I square these numbers and simplify, 7 squared is 51.84 plus X squared equals 81. So then if I want to solve for X, what I'm going to have to do is subtract 51.84 from both sides. And so that's going to give us that x squared is equal to 29.16. And then if we do the square root of both sides for that, that gives us that our x, which is what we're calling the question mark, is 5.4. So the square root of 29.16 is 5.4. Okay, so again, I know that it's perpendicular because I can see that this side here is tangent to the circle. So if I'm looking at this, this would be a line tangent. This would be a line tangent. This here down at the bottom where the right angle is a tangent line. So that's how I know that I can use that right angle based on the theorem on the front. So these are going to start to get a little bit more complicated because things are going to be missing from the diagram. So if I look at this first one and I want to find the hypotenuse of the triangle, again, it's across from the right angle of the triangle. However, the hypotenuse is this whole length. We only have 6 labeled. So see how in the diagram for number 1, they're showing us that it's the entire distance. Same thing for number 4, versus in these other problems, I don't have those long arrows. So anything that's blank means that I don't necessarily know what it is. However, I do know that the radius of the circle is the same no matter where I'm at. So if 9 is the radius, this would also be the radius. So that means that this piece is also 9 units because these 2 pieces are radii of the circle. So that means that C then is equal to 9 plus 6. So I'm going to use 15 as my C. For A and B, again, it doesn't really matter which order I'm using them. I'm just going to make the 9A and our variable B. And so if I'm plugging these into the Pythagorean theorem, that means I'm going to do 9 squared plus, and we'll just continue to call this question mark x, plus x squared equals 15 squared. So 9 squared is 81. 81 plus x squared is equal to 225 is 15 squared. So now to get x by itself, we have to subtract the 81 and then take the square root of both sides. So 225 minus 81 gives us that x squared is equal to 144. And so we shouldn't need a calculator for this one. We should know that means then that the missing side is 12. Okay, so then for number 3, it's very similar to what happened with number 2, where I am missing a piece of one of the sides. So I know that the radius is 8 on this circle. So that means that this missing piece is also 8. So what's different about this one is that I don't know the actual length of the other piece. That's what I'm looking for. So that means that C, we're going to think about that as x plus 8. So in the previous problem, it was 9 plus 6, right? So we could find the missing value from the radius and add it. Now we have a variable expression. So what that means is that when we're doing C squared, we're going to have something a little bit more complicated to start with. So we're going to have x plus 8 squared as our C squared. And then we know both A and B. So we know that A is 8 and B is 15. Remember that order doesn't matter. I'm just kind of picking the shortest side here to do this. So I've got 8 squared plus 15 squared equals x plus 8 squared. So what's going to end up happening is that the order of our operations are going to change a little bit because that variable is stuck inside the radical. So I still need to simplify this side that only has numbers. So 8 squared is 64 plus 15 squared is 225. And that's going to be equal to x plus 8 squared. So if I simplify that, 225 plus 64 is 289. So now where it changes is I'm not going to subtract 8 first because that's stuck inside the parentheses. I'm actually going to have to do the square root first. So when I square root 289, that gives us the number 17. When I square root this side, I'm left with x plus 8 now. So that means that to find my final answer, what I have to do then is subtract 8 from both sides. So if I subtract 8 from both sides, that gives us that the x that we made up as our value then is 9. Okay, so the missing piece in that triangle is 9. Okay, so the last one where we've got these tangents that we're using the Pythagorean theorem for, where we have the radius involved in the computation, we have the length of the hypotenuse is given to us as 12.5. So C is 12.5. We're told one part of the radius is x, but notice that this side is the diameter. And so that means that this missing piece is actually 2x, right? If I have x plus x, that's 2x. I'm just going to call that A and this one B. So this is going to work very similar to the last one where, since I don't just have x inside, I'm going to square root before I get rid of that 2. So if I have 2x all squared plus 6.3 squared equals 12.5 squared, that's going to allow me to solve for the x in this problem. So I'm still going to leave this 2x squared like I did on the other one, right? I'm going to leave this all inside the parentheses until the very end. Getting inside the parentheses is going to be the step after I calculate everything. So 2x squared plus 6.3 squared is 39.69. And that's going to be equal to 156.25. So since the x is on the left side with another number, I'm going to subtract that number, 39.69, from both sides. And so that gives us that 2x squared is equal to 116.56. So then when I take the square root of this, I'm going to be left with 2x on the left side. So I still have an operation that I have to do in order to solve for x. And then if I take the square root of a 116.56, that's going to round to 10.8. So I'm going to take that value as 10.8. And then if I divide both sides then by 2, that gives us that x is equal to 5.4. And for this one, because I rounded here, I should use estimation. So an approximation of 5.4 for that answer. Okay, so those were all where I have a tangent line, perpendicular to a radius, and I use the Pythagorean theorem to solve. I did have pictures where there were 2 radii in the diagram and only one was labeled. So we do have to remember to add in the measurement for any radius that's not labeled currently. The last part of this page is all the ice cream cone problems. Some of them don't look like the ice cream cone problems, but they are. So in number 5, it's asking us to find the length of the radius. So what the ice cream cone problem tells us is that these 2 pieces are equal. And so what I can do then is take 3x plus 14 and set it equal to 5x minus 8. And I have to use that to find x. And then once I find x, I can plug that into the radius so that I can get that answer. So this is the radius for x plus 7. So we're going to start by solving for x first. So if I want to get rid of or move all the x's to one side, since 5x is over here, I'm going to subtract 3x just to keep things positive. And at the same time, I'm going to also add 8. So if I also add 8 to both sides, Subtracting 3x is moving the x over from here, and so adding 8 is moving that 8 to the other side. So 14 plus 8 is going to give us 22, and then 5 minus 3 is going to give us 2x, which means that if we divide both sides by 2, that gives us a value that x equals 11. Remember though that x is not the answer, the radius is the answer. So our radius is 4 times x plus 7. So we're plugging that 11 into that value. So 4 times 11 gives us 44, plus 7 is 51. So that means that the radius of that circle is 51 units. Okay, so number 6 is actually an ice cream cone problem, even though it looks different than number 5 and number 7 look. And so the way that I know that this is an ice cream cone problem is that I can see that there are points of tangency here. So I can see that each of these lines that create this triangle are tangent to the circle. So remember that these were congruent because they came from that same outside point. So if this 16 is attached to this point, that means that the other part attached to that point is also 16. Since this 5 is attached to this point, that means that the part across from it is also 5. And finally, since this 12 is attached to this point, the other piece attached to that point must also be 12. This question is asking us for the perimeter of the triangle. So if we think about that, each of these 3 numbers, there are 2 of them. So I'm going to do 2 times 16 plus 2 times 12 plus 2 times 5, and that's going to give me the values of the perimeter. So 2 times 16 is 32, plus 2 times 12 is 24, plus 2 times 5 is 10, and so that's going to give us a perimeter of 66. Okay, so number 7 looks like number 5. However, it's not asking us for the radius, it's asking us for the length of the tangent. And so we can see that we have points of tangency here, and that these 2 lines are stemming from this same point. So again, we don't want a crooked ice cream cone because then the ice cream will fall out. That means that 7x plus 8 must be equal to 15x minus 10. So then we want to isolate x. So if I move 7x, join the 15, I don't know what my colors are changing here. So if I subtract 7x, that will move that over so that we have 8x. And then if I add the 10, that will get rid of that so that we have 18. So 8x equals 18. I can see that 8 does not go into 18, so that means I'm going to get a fraction or a decimal for this. So if I divide both sides by 8, that gives us that x is, I can divide those both by 2, so 9 over 4, which is 2.25. Okay, so it's 2 1/4 units is the value for x. Remember though that it's asking us for the length of the tangent. Since we got a fraction, it might be a good idea to check both of them just to make sure that we did it correctly. So I would be plugging into 7 times x plus 8 and 15 times x minus 10. And so if I plug that 2 1/4 in, so if I multiply 7 times 2.25 and I add 8, that gives me 23.75. And so again, these should be the same. That's how I know that I did it correctly. So 15 times 2.25 minus 10 also gives me 23.75. So I know that that is the answer for the length of the tangent. Again, it's a good idea to check it into both just because you know they're supposed to be equal to ensure that you solved it appropriately. Okay, so the last one on this page is like number 6, except they give us a little bit of different information. So I can start with knowing that these are points of tangency. So I can see that it's only intersecting the circle that one time. So since this is 20, this side must also be 20. Since this is 14, this must also be 14. Where this gets complicated is that they give me that whole length of the side as 32. But I need to be able to figure out what this blank piece is over here next to 20. And so what I can think about there is knowing that if this piece is 14, I can find the rest of it by doing 32 minus 14. So this piece is going to be 32 minus that 14. Which means that it is equal to 18. That means this piece is 18 and this piece is 18. Okay. So from there, looking at our perimeter, we have two times 18 plus 2 times 14 plus 2 times 20. And so if we calculate that out, that gives us a perimeter of 104. Another way that I could kind of think about this too is that they gave me that 32 originally, right? So I could do 32 plus 14 plus 20 plus 20 plus 18, and that would still give me that 104. So any way that you look at it, you can find that perimeter, but you still have to find that 18 in order to get the values. Okay, so the last page for this topic is 70, and so this has to do with supplementary angles. So the angles formed by the tangent segments, which is this angle here. So this is angle BCD, and the angle formed by the radii, which is this angle here. That's angle BAD. Those things are supplementary. Remember that supplementary means that it adds to 180 degrees. So the measure of angle BCD plus the measure of angle BAD must always be 180 degrees. So that means that in problem like 9, all that I have to do is subtract the known angle from 180 to get the missing angle. So here x is going to be 180 minus 130, which means it's going to be 50 degrees. When I'm doing a problem like 10 though, where I have to find x and it's in both angles, I have to set up the equation based on the diagram. So what that means is I have to take the tangent angle, which is 16x plus 5, and add that to the radius angle, which is 9x plus minus 10. And that is equal to 180. So it's not as easy. I have to actually solve this equation rather than just subtract a number from 180. So remember that if I have all the x's on the same side, I have to combine like terms. So if I have 16x plus 9x, that means that there are 25x. And then 5 minus 10, so 25x minus 5 is equal to 180. So then solving this, I'm just finding x and that'll be my answer. I'm going to add 5 to both sides. So that means that we have 25x equals 185. And then our last step would be dividing both sides by 25. So that means that x is 185 divided by 25 is 7.4. Okay, so in the next one, it's going to get a lot more complicated because we have some additional angles going on. So we have more complicated diagrams, but we're still going to be using the idea that these angles are supplementary. So I'm looking for this angle here. So let's call that x because we've been doing that consistently. One thing that I can find based on this diagram is, so this is my tangent angle. So I know that it is supplementary to this angle here. So I can figure this one out by doing 180 minus 64. So that means that this angle here is 116. So if that angle is 116, then I can think about this triangle here. Let me highlight it. This triangle here. And I know that it's a triangle, so it adds up to 180. What I know, because this is the radius of the circle, is that this is an isosceles triangle. And so because that's an isosceles triangle, what I know is that this angle is actually the same. So that means that x plus 116 must be equal to 180 degrees because it's a triangle. And so I know it's isosceles again because these two pieces here are the radii. So those two pieces are the radii, so I know that they're equal, which means that their angles are equal as well from the isosceles triangle theorem. So that means that I have 2x plus 116 equals 180. So if I subtract 116 from both sides, that gives me that 2x is equal to 64. So then if I divide both sides by 2, that's going to give us that x must be 32 degrees. So the missing angle is 32 degrees. So if we kind of think about that radius thing that we have going on, if I look at this next diagram, I know that this is equal to this is equal to this. So I'm probably going to end up right inside this triangle like we did before. And we know that these two angles here must be equal because the radius is a part of them. So since the radius is those two sides, that means that they must be congruent base angles as well. This diagram, though, is not the ice cream cone. If we think about the tangent is this line here. So that means that this one is a right angle problem. So I know that that's a right angle. So looking at the right angle, I can think about the larger triangle. So now let's think about this right triangle. And so if I think about that whole right triangle, I can find the top angle by doing 90 minus 48. Again, because that's a right angle, right? So I know that the two other angles must also add to 90, because 90 plus 90 makes 180. And so that tells us that this top angle that we know is the same as this other angle must be 42. So if this angle here is 42 degrees, that means that this angle is also 42 degrees. So now we have another isosceles triangle. And so we can take those three pieces and solve for the missing one. So I know that two angles are 42 degrees. I know that the missing angle is x, and that must be equal to 180. So that means that we have 84 plus x equals 180. And thus subtracting 84 from both sides tells us that that missing angle, which I called x, is 96 degrees. So those are all the situations with tangent where we can use equalities and other theorems to solve for a missing piece.